Hey guys, Tim here, Big Dog Forge. Welcome back. It's good to see you guys again. So this time around we're going to be building a sand muller. We're going to be recording this in a little bit of a different place. It's close to the junk pile, and we're going to use the scrap pile to build this thing. The total cost of this build was like $10. We bought a bearing. Anyway, I wanted to get through this build as quickly as possible. So there's not a lot of detail, but you get to see the full build. And then we're going to play around with some molasses bonded sand. So stick with me. It should be fun. And we'll see you at the other end. Okay, guys, we're going to move pretty quickly through this build. A sand muller. We're going to experiment with molasses bonded sand. And I want a machine because we're going to be doing several different recipes to experiment with. So we're starting with an aquarium stand. A lower third of a 55-gallon drum. We've got a industrial blower, squirrel cage type. We're going to use the bearings and shaft out of. We welded them inside that pipe right there. And we've got a cast iron wheel off an old lumber cart. So we lined the bottom of this 55-gallon drum with a piece of 3/4 inch plywood. That way we can punch these holes through here and screw that plate that's going to keep our center shaft in the bottom, and it'll stay nice and rigid. I'm going to tack weld this thing to the aquarium stand and then start building our upright supports that are going to hold our wheel and plows and scrapers, that sort of thing, to create the mixer inside this. So I did end up buying that pillow block bearing you see at the top. It was $10. I couldn't find anything decent that I wanted that would last any amount of time. So that was our expense for this particular project. Okay, so I put a pulley on the bottom of this thing, thinking about belt drive, and that evolves later. You'll see that. So the wheel, cast iron, it's very heavy. It's about 45-50 pounds, I believe. Put a shaft through it, a couple of washers. It's got a bronze bushing inside, rebar, welded it to a hinge. Welding on the side scrapers, and a little plow in the middle, and a center post scraper to push this sand around so the wheel can crush it, then we can get a good mix. All right, for the electronics, we're going to use this Selectron high-speed selective plating power pack. It's got all the electronics in it that we'll need that will create a good solid base to drive the motor on this thing. We're going to be using a treadmill motor on this, and this variac that we're pulling off of this old electrical panel will give us a wide range of variable speed. We get the shaft coming out the bottom at the moment. But the good thing about these is you loosen up the set screws around the shaft and they're free floating, so you can just tap it and it'll come out the other side. They're pretty versatile. All right, we get the knob back on this thing. We'll have to couple it up with a good sized bridge rectifier to transfer our voltage from AC to DC on the outcoming side, because our motor is a DC motor. So we got this guy cleaned up. He's in really excellent shape for sitting out in the rain in the junkyard for I don't know how many years. That's in really good shape. All right. So we need to get ourselves a rectifier and couple it up with this thing. I have several of those laying around, but we're going to borrow one of these. And this little rectifier that I grabbed here off an old power supply was from a CNC machine that I owned probably 25 years ago. And I no longer have that, but I saved the electronics from it. This is just for a little test to make sure everything's working okay. And we're going to get this thing up to around 60 volts. And everything ran fine. All right, we're measuring this out to put a piece of angle iron. We have a transmission off of a riding mower, and we're going to use that as a gear reduction. So we got it all put together and use some vice grips to clamp it in place. just for test purposes. We used a smaller variac that I use on my bench. So we drilled a hole in the bottom of the machine for sand ejection purposes after it's mixed. So I put some sand in it to test this and discovered that right where the hole is, it's ejecting right out onto the top of the belt and the pulley here. So we need to build ourselves a little chute to redirect that. And again, just a few scrap wood pieces. Came up with a little shape that I thought would work. Glued and pin nailed this together. Like I said, just to redirect the sand. So you're asking yourself, why did you put the pulley and the sand ejection hole and the belts and all that stuff right in the way? Well, this is going to sit up against the wall in the shop, and I will not have access to the back side of it, so all of this stuff really needed to be out front for maintenance and all that good stuff. So that's why we're doing this. Okay, doke. Let's get this thing slapped up under this machine. Fits between the bottom and that rail right there. And we'll put a couple of screws in from the top down. There's the hole. And we just save the wood plug out of that hole and we drop it in while we're mixing. And that's what stops the sand coming out while it's mixing. All right. That redirects that sand pretty well. All right, this is going to be our permanent variac. We got a little bit bigger rectifier to put on it and a nice little heat sink. Mounted that on a 2x6. And we're going to screw it to the bottom of this thing, and that will be our permanent power supply for this. You can get a little bit of an idea of what that looks like inside. And this is a shot of the outside, and this is pretty close to complete. We'll take a close look here under the hood, and you can see where I welded a sprocket from a bicycle directly to that pulley, and we just use a bicycle chain for our final drive to the drum. All right, we'll get some sand in this thing and a little bit of molasses. I think we need to stop this machine to put that molasses in. You're getting it everywhere, you goof. Anyway, there we go. So we had a little bit of a problem here, and the issue is that the gearing is just a little too high. We need it a little bit lower. You've got to turn the variac up quite a ways to get it to start up on some of this. And then you get sand kind of spraying everywhere. We want a little more control there. So the way we're going to do that is we're going to change the gear reduction on this guy. So it's mixing the sand up just pretty as you please. And we'll see how this ejects from the machine here. We get the plug out of the bottom of the machine. There we go. Set that aside and flip her on. And this is working pretty good. We're missing the bucket there a little bit. Okay. So did a bunch of research on this particular type of sand. It's used in a lot of places around the world. Not widely used here in the U.S. Only seen a couple of videos on YouTube, mostly by a gentleman or a YouTube channel calls himself Groucho's Garage. Check it out if you get a chance. Anyway, so what we're going to do is use this particular sand, and we are going to mold up a pulley so that we can give ourselves a little better gear reduction at that transmission. So we're going to make a bigger pulley. And I am going to pretty much follow the descriptions and everything that's been given to me as to how to do this. And you would not believe how this sand feels once you compress it by walking around on it. It's amazing. This stuff compacts and holds its shape so well. And it's not sticky. It doesn't grab things. I will say the more cornstarch you get on things, the more definition they have. The sand I used here was a little bit on the coarse side, I would say. It's like a filter sand, and it's pretty fine. And I screened it again. Yeah, I climbed up on the bench, fat guy on the bench, and walked on both sides of this thing. They put a feeder in, or a sprue you might say, and cut a channel over to the item. In this case it's pretty small, so I'm not going to worry about venting this at all, and we're going to see how it goes. And once you scrape the top down flat, you roll it out, it compresses it even more, and this stuff just, it does a fabulous job. This is the first mix of this I've done. I'm sure I'll be able to improve it over time, maybe get a little finer sand. Just cut a little gate here and mold that in so there's no sharp or loose edges, and we'll pop this guy out, and he came out really clean. And by all rights I should not have blown that extra cornstarch out of the mold, but I did, and I poured it a little too hot. And the reason I say that is not because of anything that's happening here, but when I pull the pulley blank out of the sand, it is dark brown. It's got a brown coating on it, and that's me burning the molasses by pouring this a little too hot, from what I understand. So the stuff that's burnt you don't reuse. You knock that off and throw it away. And I could have let this cool a little bit longer. It would have been a little bit better. And it didn't come out too bad. We can get this over to the lathe and machine it up. There's our blank. And there's our pulley after machining. So not too bad, not too bad. Yeah, nice. Okay, here we go. We pulled the 1 1/4 inch pulley off. And this is like a 3 inch it ended up being, once I machined it all down, 3 1/4, something like that, inside dimension, V-belt, blah blah blah. Anyway, it's bigger. There we go. And I'm not doing the math for the gear reduction and the ratios, so, because it just works. This is a junkyard thing, it gets junkyard math. Okay, we'll get this motor tightened up and loosen up our pivot. Slide that motor over, tighten the pivot up, and we are good to go. All right, guys. There she is. So thanks for stopping by and checking out Big Dog Forge. Really appreciate it, and we'll have a new video out soon. Thanks, guys. See you soon. Take care, and be safe. Bye now.